Good afternoon. I'll wait a little bit to see if anybody else joins us. Okay, so about 2:05. There we go. So, oh. Okay, good afternoon. We are going to go ahead and get started here in a minute. We've got one more file that I want to have out. Let's see this one. I think maybe this one. Mhm. Yeah, that's one. Okay, here we go. Now we can share screen. Okay, so I am, sorry, this does that every time. Going to the module so you can see where I'm going. Okay, here we stopped here, right? So there's your lecture, and we are going to look at metric prefixes and units first. This one right here. Okay, so when you're looking at metrics, you have to remember that this is widely used. We don't use it in the United States, but it is a very widely used system. As a matter of fact, we're more like the exception than the rule. They use it all over the world. And as you can see, it was in 1960 that they decided to update it for the whole world. And as a matter of fact, there is a meter that is made of gold, because gold doesn't expand as easily, in France, where it is called the gold standard. You've ever heard of the gold standard? Well, that's what that comes from. And you always will have two different types of units. There are base units and derived units. Okay, so the base units are independent and they're based on just whatever you're measuring, whatever parameter you're measuring on that object or on that measuring period. One of them would be in time. Of course, you know time. But the base unit for time is seconds, and it's abbreviated S. Mass is kilograms, and of course, it's abbreviated kg. The amount of substance, which is unique to us in chemistry, is the mole, and abbreviated MOL. Electric current, that's in physics or engineering, you know, it's the amp or ampere, as capital A. Luminous intensity, that is how bright something shines, that is a candela, CD. Length, meters, that's what we use. And temperature is Kelvin. It's not Celsius. Most people think it's Celsius, but the metric system is Kelvin. We will look how to convert between all of those. Here's some prefixes and their values. Now, if you put a prefix in front of any of those base units, it takes on the same value. So if it's a gigameter, then it's 10 to the 9th meters. If it's a gigasecond, then it's 10 to the 9th seconds. If it's a giga, you know, whatever it is, it's 10 to the 9th, okay? So that's how it works here. And there's all of your prefixes, which you have, and I'll show you where they are. And then you have also known as derived units. If you noticed, one of the major parameters that we measure, which is volume or characteristics of matter that we could call it, is volume. And we didn't have it in the base units because it happens to be a derived unit. So it couldn't be in the base units. And an example of another one is speed, and then you have density. And we will look at density also. Density is just grams per centimeter or mass over volume. So it's a derived unit over a derived unit. You know, it's a derived unit made by dividing it on a derived unit. So all these units can be used to do different things. All right, so volume is very interesting because you ever heard length times width times height, right? Well, that's how you get the volume of something that is measurable. And it's used for solid objects with a regular shape. And milliliters or liters are used for liquid, but they are interchangeable. And as you can see, 1 centimeter cube is exactly 1 milliliter, and 1 decimeter cube is exactly 1 liter. Now, density, like I was telling you, is a ratio that compares the mass of an object to its volume. So you have mass and volume as grams per centimeter cube or grams per milliliter, or you can have kilograms per liter. I mean, there's all kinds of variations as long as it's a unit of mass or a unit of volume. Temperature is the other variable that we're going to measure, not measure, but calculate and convert. What it is the relative measure of the hotness or coldness of an object. It also, which is really sounding kind of, you know, not a real definition when you hear that, but temperature is also the average kinetic energy in a system, right? So if you have more kinetic energy, you have more temperature. If you have less kinetic energy, you have lower temperature, right? So higher temperature, lower temperature, all related to the movement of the particles. And here you go. You have two temperature scales, Celsius and Kelvin, but the actually Kelvin is the base unit. Celsius to Kelvin, you add 273. Kelvin to Celsius, you subtract 273. You might want to write that down, although I give it to you also later, but you might want to write that down. And a lot of the people say 273.15. When you do that, then you cannot get a zero, which is one of the reasons I don't use the 0.15. All right, and that's that for that one. All right, so that was here. Now we're going to look at the metric system. That's the next PowerPoint that I have open already. Oh, not this one. Sorry. Okay, I did have it open, but I guess by closing that other one, I closed it too. Darn. Okay. So metric system is the next one. Come on, let's go. I'm just going to download it. And open it. See, this is what happens every time. Always get this sheet that's very strange with all these scribbles. We don't need that one. We need this one. Right. So in order to convert, it's very easy. You have two methods of doing it, and I'm going to show you a third one that I like better. I created this one, sort of. Okay, so you find the difference between the exponents of the two prefixes. The only problem is a lot of people have problems when it's negatives and positives, and they don't know what to do, whether to keep adding or subtract or what. Okay, well, you just find the difference between those exponents and move the decimal that many places. And I see there once again, are we moving it to the right or to the left? Well, we don't know yet. We are moving it one way or another, and it all depends on what we're converting. Okay, so you see, when you do 532 meters, meters are smaller than a kilometer. So of course your kilometer is going to be smaller because you only have a part of it, right? When you convert it to kilometers, you're still converting the same number. So it's just going to be smaller because kilometers are larger. Therefore, if you have meters, you only have a portion of your kilometer. To remember that. And it's easier if you remember it this way. If you're going up, you move it to the left, or it's negative, negative exponent, which is the same thing. If you're going to the right, to the bottom, top to bottom, you're moving to the right, and that's a positive exponent. Okay, so this is the other way, the factor label. Okay, so what you do in order to change it, you factor out the one that's common, and you get the answer of the one that's the only one that's by itself. So how do you do? Here's your steps. You first need to identify your starting and your ending units. Then you line up your conversion factors so that the units will cancel. If you have to flip them, flip them. But remember, as they're written, that's how they should be every time. So you don't say 1 kilometer is equal to 1,000 meters and 1,000 kilometers equal to 1 meter. No, that's backwards. Okay, so you have to pay attention to what's with what, like the thousands with the meters and the one is still with the kilometers. Then when you flip it, when you reverse it, it'll be 1,000 on top, but it'll be meters, and 1 on the bottom, and it'll be kilometers. It just depends on what you're looking for. And we'll do a problem or two so that you understand it. And then you multiply all the top numbers and divide by each number on the bottom. Okay, so basically, if you have multiple, that's how you would do it. And then you check your units in your answer. And this is where I introduce this thing called the SURE method. And I will explain what that means. It's just an acronym that I use. It's called SUR. So sig figs, you have to check those. Make sure you have the right units. And is your answer reasonable? I mean, if you for some reason you're changing meters to kilometers and you get a larger number, that's not reasonable, because we just said that kilometers are bigger, therefore you should only have a fraction of it, right? So that would not be reasonable, and then you would know that something went wrong. Okay, so this is what I call the SURE method. You check your sig figs, your units, and then you think about it and say, this sounds reasonable to me, or it doesn't. And you'll see you'll develop that. Okay, so let's go next to a problem. Okay, so here's how we're going to change 1 inch to a centimeter. See, inches to centimeters, that's the equivalence. The equivalence, depending on where you're going, that's how you line it. So if you're going to centimeters, then you say 1 inch is equal to 2.54 centimeters, right? And you line it up. See? So how many milliliters are in 1 quart of milk? Okay, here's a question. Remember the steps. Line up your beginning and your ending units, which we've done here. We're starting with quart. We want to end in milliliters. Then you find your conversion factors. And I'm going to go ahead and stop right here so I can show you where they are on your module here. So you can print them out and have them ready for yourself every time that we do this. Okay, sorry, there we go. We're here and it says metric conversion chart and metric to English conversion chart. You want both of those, okay? So remember, get metric conversion chart and metric to English conversion chart. I'll show you what they look like. The metric conversion chart is what I call the ladder, because it's like a ladder. You have rungs, and some of the rungs are empty. Someday it'll load. Maybe I should just download it. Let me just download it because this is taking way too long. Okay, there we go. There we go. Okay, so for this one, it's the same thing that we saw before, except I've added quite a few, but I've also added extra spaces, and you'll see how to manage that once we are trying to do both. I mean, we can do lots of different things with the conversions. We can use this method, we can use the counting method, which I don't like, subtract, when you count the amount of spaces, the amount of difference, and then you subtract, but then it gets confusing. So that's what I was saying. But it always is the same way. If you're going down, then you're going to have a positive exponent. Remember, like in scientific notation, if you're going up, you're going to have a negative exponent. Okay, remember that. All right, so for this, you want to print it out because we've got every single possible, every single possible. Yeah, I've gone up to peta because terabytes is something that you can go buy right now. So I figure we stay one ahead and we go all the way to peta. And then there's more than that too. And then auto is something that is there. Femto, pico. I know you've heard nanometers for sure. If you've been in biology, you've heard nanometers. Picometers, femtometers, and attometers. All of these are there. There's quite a few prefixes. And they all have a certain value and a certain way to abbreviate it. So make sure that you do that correctly. All right, so that's that one. I'm just going to bring it down and erase all these. Okay. All right, and the other one that we have is, actually, I probably should have just gone after that one, but that's all right. It's the metric to English conversion chart. And this one, we always keep adding to it. You can always add to it. Let me download it because this is going to take too long. Okay. Here it comes. Okay. So like I said, we always add to it. Right now, we could add volume. We could add 1 centimeter cube is equal to 1 milliliter, right? And 1 decimeter cube is equal to 1. So if you were going to do that, what you can do is, first of all, when you download it, you need to enable editing. Come on, let's go. Okay. And we're going to add another 2 insert rows below. We're going to add 2 to them. Okay, and there we go. So we're going to say volume. We're going to add this one. Remember, it was 1 centimeter cube. Oops. Sorry, 1 centimeter cube is equal to 1 milliliter. And we know that 1 decimeter cube is equal to 1 liter. And we're going to have a few more. We may have them already, but throughout the whole time that we're doing this, we're going to end up getting more. And I just like to make it pretty, so I'm just adding extra spaces so it'd be more. And there you go, like that. You can just keep adding to it if you download it. If you print it, you can just add it, but by drawing another row there. Okay, so as I was saying, we're just going to keep these handy. All right, so we are now going back to our PowerPoint, where we are asked to convert. No, not this one, the other one. Oh, no, that is it. Okay, never mind. There we go. One more. There we go. We are here. Okay, so don't look at what's already there because I'm not supposed to be showing. Okay, so first step is that. Then is find your conversion factors. Okay, so we know we want to go from quarts to milliliters. So I don't know if you noticed, but on there was a quart to liter. And I'll show you this here. See, there's a quart to pint, but there's also a quart to ounce. And then there's a quart to liter right here. See, 1.06. Okay, so we got that one in our head now. So we know we have that. And then milliliters to liters, that comes from the other one. And we'll look at that one in a minute. Okay, so your first thing is to line up your conversion factors. You can do it this way, or you can do it as a set of lines. Oops, sorry. I meant to say lines like this and multiplications, right? You can do it that way too. I like the boxes because they're neater. And now there is no doubt in my mind which one goes above, which one goes below, because it's all one straight line. Okay, so we know that 1 liter is 1.057 quarts. Okay, they are being a little bit more sig figs in here. We only added 1, 2, 3, prefix, which is 1.06. Here they have 4. All right. The next thing would be to change liters to milliliters. And I'm going to show you how to use that particular thing that I was telling you about. This one. Okay, so we want to go from liters, which is called the unit, right? Because the unit has no prefix. So right here, this is our unit, right? So I'm going to highlight it so that you can see where we're going and where we're coming. Okay, so we want to go from here to here, right? Okay, so what you do is you treat it as a ladder. And remember, going down is a positive, right? So you got 1, 2, 3 steps. So whatever the number is going to be written. So let's say 1 liter, right? Goes on top. And on the bottom, you can put 1 times 10 to the third milliliters. That's what we know. Now, I think we're going to have to flip this because I think the liters are on the, well, we'll have to look at it. But remember this equality. That's one way of writing it. But you see how easily we got it? We just said we're here. We're going to go 1, 2, 3. So you don't count the one where you start because you're already standing on that rung, right? If this is a ladder, you're going to go down 3 steps because you're already here. So this is step 1, step 2, step 3. And since it's going down, this is a positive exponent. Up would have been a negative. Okay, remember that. See, this is positive right here. All right, so that's how we use this one. Let me go, oops, let me get my mouse back. Okay, so we wrote that, and we kept it. So let's keep going. All right, the next step for this one would be to change it. And see, I told you we'd probably have to reverse it. So just think of it as rotating on its axis and flipping over. So in this case, we're going to say that cancels. Now we need liters on the bottom and milliliters on the top. And I don't know why on earth this is weird like that. Oh. And that would give you, that is so weird. Why is it doing that? Let me see. I'm gonna have to escape it just to fix it because yeah, that's what it is. This got shortened. There we go. Now it's right. All right, so we can look at it now correctly. Okay, so there we go. And 10 to the third, as you know, is 1,000. And like I said, all you have to do is just flip it around. Take the 1 liter, put it on the bottom, take the 1 times 10 to the third, put it on the top. And if you do the 1 times 10 to the third, it still works, okay? It doesn't have to be 1,000. It can be 1 times 10 to the third, which is exactly the same number. No problems there. Okay, let me get my calculator. Not that I need it, but what I was going to do is I was going to show you that when you're doing this kind of operation, okay, it has disappeared. It's in here. Oh well. Where put it? Oh, there it is. Okay, it was under a paper. Sorry. Okay, so what you would have to do would be multiply 1 times 1,000 and divide it by 1.057. Okay, so if you were to do it by multiplying it times 10 to the third, right, like we said, then it would be okay, because 1 times second e to the 3, which is 1 times 10 to the negative 3, I mean the positive 3, divided by 1.057 is going to give me exactly the same number. which is 946. And remember the sure method. We had 3 sig figs on the, by the way, every single one of these is an equality, so they do not count as your sig figs. The only sig figs comes from the 1.00, and this one has 3. So now your answer is 946. Okay. Now, if it had been 1.000, then you need the next one, which is 0.1, sorry, 0.1, because it's 07. But you don't. Okay, and like I said, we needed to flip this one around. So basically what we would do, since we need the liters on the bottom, right, is we would flip it. And we would just say 1 liter is equal to 1 times 10 to the third milliliters, because we needed milliliters on top. And see, that would still cancel and give you milliliters, like we said it should, right? Okay, that's one. And it does make sense because 1 quart smaller, right? And we're converting quarts to liters. So we'd expect less than 1,000, and that makes sense. So that's the sure method. You have units, you have your sig figs, and you have the reason behind it, the reasonable thing. All right, let me clear all of these and keep going to the next question. Okay, so we have several problems that we're going to look at like this, and then you're going to do some. Okay, it says you have 1.5 pounds of gold. Find the volume of gold if the density is this. Okay, density in this case is just being used to convert from mass to volume. So you're setting it up. Remember, first thing, you're going from pounds to centimeter cube. Why do we know? We know the pounds, right? That's the first thing. So we need 1.5 pounds here. Then we need to go to our conversion factors that we have and see what is between pounds and kilograms or pounds and grams or pounds and something. Okay, I have pounds and kilograms here, and I have also pounds and grams. So I would use this one because it's shorter. That's just me, okay? But we have it, but they are not giving it to us. So they're using the kilogram one, okay? So we're going to use that. That way we also have another opportunity. We're going to go to this one and we do the kilo, right? We kilo to the unit. So once again, let me undo this highlight, or just do a different color highlight. How's that? Let's just do green. Okay, so this time we're going from kilograms, right, to grams, which grams is the unit, by the way. Okay, so we're counting, and we're counting from top to bottom, right? So 1, 2, 3. So it's 1 times 10 to the third. So in this case, 1, we're going to write it down, 1 times 10 to the third grams and 1 kilogram. Okay, that's what we're doing. Now, let's go back to our original PowerPoint. And here we go. Okay, this time I wrote it correctly because the kilograms is on top. So we could just use this, or we already know that 10 to the third is 1,000. So we can just do that next. Right? And then after that, you see how we have this unit right here? Okay, in this case, since the grams are with the 19.3, the 19.3 has to go on the bottom. And then the centimeter cube goes on top. And as you can see, grams will cancel and we'll end up with what we wanted, which is centimeter cube. Now, all you have to do is multiply 1.5 times 1,000 and divide it by 2.2 and 19.3. So in my case, I'm going to do that. And it's going to be 1.5 times 1,000 And I just use divided by, and I open another parenthesis and say 2.2 times 19.3, close it and hit equal. And I get 35.3233. Okay, we only have two sig figs. So 35.33 is going to be 35, right? That's our answer. Okay. Oops. There you go. There you go. 35 centimeter cube. See? So are you understanding so far how to do the dimensional analysis? It's pretty, I mean, if you let the units guide you as to what to do next, the units will never lead you astray. You just got to place them in the right spot. That's all. And that's the main thing. And the way that I always say is where you're coming from comes on the top. Then, of course, where you're coming from needs to be on the bottom. Then where you're going to, coming from, going to, coming from, going to. So wherever you're going to, it may take several steps, but every time that you're going somewhere, it needs to be on top. So if you're going from pounds to kilograms, the kilograms need to be on top. If you're going from kilograms to grams, the grams need to be on top. Grams to centimeter cube, the centimeter cube needs to be on top. You see how that works? One of the things that I always also teach my students to do, and that's you guys, is doing this. Look, making a path and then figuring out based on what you actually have. See, that's a path. And look at all of the ones that are on top. The ones that are on top are the ones that need to be on top, which is where you go each time. Now the equivalence needs to be on the bottom, whatever it's equivalent to needs to be on the bottom so that it can cancel as you go across. All right, let's clear these. And let's go to another one. Okay, how many liters of water would fill a container that measures 75.0 cubic inches? Here's a question, very good question. Right, so we're going from cubic inches, right, to liters, because obviously we know the number of cubic inches, but we have no idea how many liters. So that's our question. Right, so cubic inches. We need to go to our conversions, and you got inches to centimeter cube. You see that? So we need this because we need to somehow convert that to metric, right? So inches to centimeters, okay? So the first thing to do is to do that. But since it is in cube, you need to cube both numbers. Obviously, when you cube 1, it's going to still be 1, and it's just going to be cubic inches. But when you cube 2.54, you have to multiply it times itself twice, right? So 2.54 times 2.54 times 2.54. So obviously, if you don't have a calculator that'll do that, but you should, you can just use the little, I call it the Chinese hat, people call it the house top, you know, the little elevation, elevated to the power of kind of thing. Okay, so that's your next step. Now, after you got that, how would you go to liters? Remember, we just said over here, once again, that 1 centimeter, right, is equal, cube is equal to 1 milliliter. So now we know that next step. And that's just to change it. Okay, but that means that 1 liter is going to have 1,000 cubic centimeters, because 1 liter is, and 1 centimeter, 1 milliliter and 1 centimeter are the same. So when you went to this other one and we did liters to milliliters, right, again, which was here, liter unit to milliliters, it was 3. So that was 1,000 again. See? All right. So now we are making sure that these cancel, and they do. We multiply 75. Don't forget to cube that 2.54. So 75 times. And then you can put parentheses and put 2.54 and then put the little house top to the third. Close those parentheses and hit equal. That gave you that number, and then divide it by 1000. And that is going to give you a number like 1.22. And does that make sense? Yes, it does. Okay, 1.229, so 1.23. We have 3 sig figs, so we need only 3. 1.229 becomes 1.23, and that is correct. All right, now look at this one. Your European hairdresser wants to cut your hair 8 centimeters shorter. How many inches will he be cutting off? Okay, we know that centimeters and inches are a direct thing. We found it already. So we know that 1 centimeter is equal, no, I always get those two backwards. 1 inch is equal to 2.54 centimeters. Yeah, so centimeters has to go on the bottom. And then just all you have to do now is divide 8 into 2.54, right? And that gives you 3.15. And in this case, 3.2, right? Because we need 2 sig figs. And there you go. That one was an easy one. That's what is known as a one step. We've been doing multi-steps. Okay, here's another one. Taft football needs 550 centimeters for a first down. How many yards is it? Okay, let's go looking. Do we have anything that connects centimeters and yards? Okay, got centimeters to inches. We got meters to yards. That's meters to feet. Okay, and then we got mile. No, we don't want mile. Sorry, we want centimeter to inches, and maybe inches to what would you want to do? Inches to centimeters and then to yards, I guess. That would be good. All right, let's see. Let's do that. Okay, we have agreed. Okay, so we're going to from centimeter to inches. And then we know that every yard has 12 inches, or every foot, sorry, has 12 inches. And every yard has 3 feet, right? Okay, so now we are able to do what we were asked to do. You notice there's nothing on the top, they're all on the bottom. Okay, so we need to put 550 divided by, and then use a parentheses and say 2.54 times 12 times 3. Close the parentheses, hit equal, and you get 6.01 or 6.0, because over here we only have 2 sig figs, right? Because that last one does not count because it doesn't have a decimal. So it is just a trailing zero with no decimal, doesn't count. So our answer has to have 2 sig figs, and that makes it 6.0 yards. All right. This example right here is one of those that's a little bit different as far as the sig figs go, and I'll show you why. When you are cutting a piece of wire, if you have a remnant, is it going to be 1.5 centimeters? No. Therefore, your answer, if there is a remnant, is only a whole number, right? Because you can't have part of a 1.5 centimeter piece and call it a 1.5 centimeter piece. So this is how we're doing it. Okay, so we got 1.3 meters. We're going to change meters to centimeters. Okay, so to do that, we're going to go here. And no, not that one. Sorry, wrong one. I'm going to go here. All right, so I'm going to make that one a different color even. Let's see. Let's make it a pink. Okay, so we're going from meters, which is our unit, right, to centimeters, which is right here. So we're going 1, 2, just 2 down. Okay. So now that we know that, we need to put here that for every 1 meter, there's 1 times 10 to the second centimeters or 100, either one. Then next procedure would be to say every piece, right? 1 piece is equal to 1.5 centimeter. How many pieces do we have? Okay, once we multiply, divide, we're going to get a number. And that number, remember, 1.3 times 100 divided by 1.5 is going to give me a remnant, and that is 86.67. Now, if I have 86.67 pieces, one of those pieces does not meet the criteria. That's the 0.67 one, right? So that means we only have 86. This is a peculiar one because of the way that it's written. All right. And that's that. All right. So you guys get how to convert. Next time we will do, I wish I could, but yeah. Next time we will do more conversions with, let's see, hold on, let me go back to my module so that I can show you where we're going to go next time. And that way it'll be ready for you. Okay. So we have covered this. We are going to go ahead and do this dimensional analysis. I'm going to let you guys do a couple of these. Then we're going to go to our measurements and calculations. You know, that's an okay thing. I mean, we already went over it, so we're good with that. But after this, we're going to go and do some density. Okay. So the density formula triangle is something that I use for people because a lot of the times people think that it's difficult to solve. Well, with the density formula triangle, the way that I have it written, if you cover whatever you're looking for, so let's say you're looking for mass, so I'm just going to highlight it. Let's say you're looking for mass, right? So we're going to highlight mass. So we cover, oops, I'm sorry, that was not meant to happen. Okay, there we go. So we cover it, right? So imagine that that's gone. So mass is equal to density times volume. See how the density and the volume are on the same plane? All right. So what if we don't want to do that? What if we want to do density? Well, density is going to be mass over volume, you see? So if we don't want to do density, we do volume, and then we can just see that then volume is going to be equal to mass over density, you see? So it just kind of makes it, whichever one you're looking for, you just cover that one, and the relationship reveals itself with this triangle. Instead of you having to go volume, you know, density, this mass over volume. If I want to solve for volume, what do I do? Oh, it's a lot. It's a bunch of steps because it is on the bottom. So, you know, you have to multiply everybody by volume and then get rid of that. And that gives you density. No, yeah, first. And then you got to solve for volume again and so on and so forth. So it kind of makes it a little complicated. But in this case, it shouldn't. All right, so we are going to stop it here. Well, there's no drawings to clear, never mind. And I will talk to you ladies next time. And I will put you in as present since you're here. All righty, and make sure that you download these two things. And don't forget your homework that you are supposedly due. Let's see, we have two. Tell me if you can see it, because somebody said, what homework? And I'm sure that it says it right here, January 19th, right? That one said January 16th. And then down here, we had the scientific notation and significant figures. Right here, assignment, that one is January 19th. And then this one was January 26th. That one was also January 26th. And now we will open the scientific method assignment. It's already open, sorry, not we will open it. It should be already open. And that'll be the one that you'll be working on. And when we finish the metric, the conversions, then you'll be doing that one. All right, and that's it. So I'll see you next week. Bye.